In this video lecture, we're going to discuss binary arithmetic. Specifically, we're going to discuss single bit addition with carry, multiple bit addition, single bit subtraction with borrow, multiple bit subtraction, and multiplication. So let's start our discussion with single bit addition with carry. So given two binary digits, x, y, a carry in z, we get sum s and carry z. Okay, so z is different from c. Z means carry from the lower position, while c will be carried to the next higher position. So let's consider first z equal to 0. So nothing to add from the previous or from the lower position. So let's have this. So z plus x plus y. So 0 plus 0 is 0, plus 0 is 0 carry 1. 0 plus 0 is 0, plus 1, 1 carry 0. 0 plus 1 is 1, plus 0, 1 carries 0. While for 0 plus 1, it's 1, plus 1, 0 carry 1. Why do we have carry 1 when we add 1 to 1? Again, what is the highest position in binary? It's 1. If you're going to add 1 to 1, it means you're going to exceed the highest position, the highest value in a position. Therefore, we need to go to the next higher position. So that's why we carry 1. Okay, go to the next higher position if we exceed the highest value in a position. Okay, so that's the meaning of carry. So let's consider z equal to 1. So 1 plus 0 is 1, plus 0, 1 carries 0. 1 plus 0 is 1 rather, plus 1, 0 carry 1. While 1 plus 1 is 0 carry 1, plus 0, 0 carry 1. While 1 plus 1 plus 1 is 1 carry 1. Okay, so if we're going to add it by pairs, 1 plus 1 is 0 carry 1, plus 1, 1 carry 1. Okay, so based on this, let's have examples. More than one digit or more than one bit. So let's add these numbers. 1100 plus 10001. And the carry from the previous or from the right position is 0. So let's add. 0 plus 0 is 0, plus 1, 1. 0 plus 0, 0, nothing to carry on the next higher position. So we have only 1 plus 0. Result, 1. Nothing to carry. So 1 plus 0, 1. Nothing to add to this one, so therefore just bring it down. So the final answer is 1, 1, 1, 0, 1 for these two values. Okay, so let's have another example by adding these two numbers. 10110 plus 10111. And again, no carry from the right side position. So let's add. 0 plus 0 plus 1 is 1. Nothing to carry. So 1 plus 1 is 0. It exceeds the highest value in this position. So therefore, we carry 1. 1 plus 1 plus 1 is 1. Carry 1. 1 plus 0 plus 0 is 1. Nothing to carry. So 0 plus 1 plus 1 is 0. Carry 1. And nothing to add to this one, so just bring it down. So the final answer, or the sum of these two numbers, is 1, 0, 1, 1, 0, 1. Okay, so that's how we add in binary. So let's proceed with subtraction in binary. So let's have xy to be that we're going to subtract, borrow z, and different s, and borrow b. So xy, okay? So 0 minus 0 is still 0, and we didn't borrow. 1 minus 0, 1, and we didn't borrow. That's why it's 0. 1 minus 1 is still 0, and we didn't borrow. That's why it's 0. 1, 0 minus 1, result is negative 1 or 1, 1. Negative is represented by 1 on the leftmost side of the answer. Okay, this is how we represent negative numbers in binary. The leftmost side of our digit will represent the um, the sign. If it's 1, it means negative. If it's 0, it's positive. So that's why negative 1 can be rewritten as 1, 1. This one is representing negative number. Okay, but the question is, why do we have a difference equivalent to 1 when we subtract 1 from 1, 0? Okay, so using borrow 2 rule, so we all know that 0 minus 1 is cannot be. So we borrow value from the next significant digit, which is 1. So when we borrow value from this position, 1 will become 0. And when we transfer the 1 from this position going to this position, it will become 2. Why 2? Because one value in this position is equivalent twice in this position. Okay, if still remember, this is 2 raised to 0 for the first position. Second position is 2 raised to 1. So first position is 1, the weight is 1. Second position is 2. So second position is twice as big as the first position. So therefore, when we transfer one value from left to right, we multiply it by 2. So that's why borrow 1 will become 2 from left to right. Okay? So 2 minus 1, 1. And since we borrow, that's why we have negative here. Since there is no value after this digit. So just to represent it is negative. So use 1 or use dash. Okay? So let's have an example for more example about subtraction. So let's subtract this. 1, 0, 1, 1, 0 minus 1, 0, 0, 1, 0. So 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is still 0. 1 minus 1 is still 0. So therefore, this is our answer. Another example. 1, 0, 1, 1, 0 minus 1, 0, 0, 1, 1. So let's start with this position. 0 minus 1 cannot be, so we borrow 2 from the higher position. So this one, okay, when we transfer to the right side, it will become 2, and this value will become 0. So 2 minus 0, 2 plus 0 is 2, minus 1, 1. Second position, 0 minus 1 cannot be, so we borrow 2 from this position. So 1 will become 0, and then when we transfer it on the right side, it will become 2. 2 plus 0, 2. Now we subtract 1 from 2. 2 minus 1, 1. Okay, now third position, 0 minus 0, 0. 0 minus 0, 0. 1 minus 1, 0. So this is our final answer. This is our difference when we evaluate this given. Okay, so that's how borrow 2 works. So there are other approach in subtracting binary, so it will be discussed further on your computer organization and architecture. So basically, we are using complement, single single complement and double complement. It will be discussed further in computer organization. But here in logic circuit, we're just going to discuss borrow to rule. Okay, so now let's proceed with binary multiplication. This is the easiest arithmetic operation in binary. Okay, so when you multiply 0 to any value, we know the result is 0. So that's why 0 times 0, 1 times 0, 0 times 1 is equal to 0. And 1 times 1 is still equivalent to 1. Okay? And whatever the rule that we are applying in decimal, it can be applied in multiplication of binary. Okay? Same rules. So let's have this example. 1011 times 101. So let's start with the rightmost position. So multiply, just copy since this is 1. 1011. Second position, so we're going to skip the first position, proceed with the second position 4. When we multiply second position with this number. Since this is 0, so just put 0. And then for the third position, we start with the third position here. Since this is 1, so just copy and then add. This will be our final answer. That's how binary multiplication works. So easy. Okay? So in the next video lecture, we're going to discuss data encoding. See you on the next video lecture. Thank you for listening.